Compound statements are more complex statements built by incorporating statement variables with logical operations. This means that we take statement variables such as little p and little q and connect them with logical operators such as not, or, and and to make a new and more complex statement known as the compound statement. It is convention to denote compound statements using capital letters. Here are some examples of compound statements capital X and capital Y. In this subsection, we'll learn to translate English statements into compound statements which are in symbolic form. We'll go straight into the translation of English sentences to symbols, but just a couple of special cases to take note of. A sentence in the form of P but Q is taken to mean P and Q in logic. For example, if I say, I am poor but happy, then I really mean I'm poor and I'm happy. A sentence in the form of neither P nor Q has the same meaning as not P and not Q. For example, if I say, I'm neither rich nor powerful, then I'm really saying I'm not rich and I'm not powerful. In this example, we have to translate from English to symbols. Let's keep these special cases in mind. Now we are given that little h represents Ewan is hungry and little s represents Ewan is sleepy. How should we translate these sentences to symbols? Part A says, Ewan is not hungry but is sleepy. Remember, the word but has the same meaning as and. This is equivalent to saying Ewan is not hungry and Ewan is sleepy. Using the given statement variables, Ewan is not hungry is translated to not H. And is replaced by the and operator. Ewan is sleepy is translated to S. Next, part B says Ewan is neither hungry nor sleepy. Remember that neither nor has the same meaning as not P and not Q. So this sentence is equivalent to saying Ewan is not hungry and Ewan is not sleepy. Using the given statement variables, Ewan is not hungry is translated to not H. And is replaced by the and operator. Ewan is not sleepy is translated to not S. And you're done. In this exercise, we are given that little a represents John likes apples, little b represents John likes oranges, and little c represents John likes grapes. And we are to translate the following into symbols. Part A says, John likes apples and oranges. That's the same as John likes apples and John likes oranges, which is equivalent to little a followed by an and operator followed by little b. Part B says, John does not like grapes. That's the same as it is not true, or it is the opposite of John likes grapes, which is equivalent to not C. Part C says John likes apples or oranges. That's the same as John likes apples or John likes oranges, which is equivalent to A or B. Part D says John likes apples but not grapes. Since but has the same meaning as and, we can also say John likes apples and John does not like grapes. That's equivalent to A and not C. Part E says, John likes neither apples nor oranges nor grapes. Since neither means not P and not Q, we can also say John doesn't like apples, and John doesn't like oranges, and John doesn't like grapes, which is equivalent to not A and not B and not C. Part F says John likes neither apple nor grapes, but he likes oranges. This is equivalent to John doesn't like apples, and John doesn't like grapes, and John likes oranges, which is then equivalent to not A and not C and B. Part G says John likes grapes and either apples or oranges. This is equivalent to John likes grapes, and the part which says either apple or oranges can be brought together using a set of brackets. Using statement variables, we should get C and open bracket A or B and close the bracket. In summary, we have learned that if we combine statement variables such as little p or little q with logical operations not, or, and and, we'll end up with a new and more complex statement called compound statement, represented by capital letters. We also learned to translate English statements to symbols. In particular, P but Q means P and Q, and neither P nor Q means not P and not Q.